Okay, so I gave this copy to you just now. So only short of the last chapter. So there are a lot to cover. I think some of them you can just bring along with you and then look at them. So physical quantities, you need to remember the units for this field. So if you are still not familiar with it, then mass is, the unit is kilograms, temperature is in kelvins, length is in meters, current is in ampere, and then time is in seconds. Then the prefixes is more for conversion of units. This is more commonly used. Then you can remember the symbol. Symbol is required. This you don't really have to. This you don't have to. So if you know the value, then they will help you. This will help you convert your units. So if you have not remembered this, you might want to do last minute. Just try to remember some of them. So based on this, right, to convert your units, you will use this. So if it's converting from base unit means uh these are base units. So kilograms, Kelvin, meters, all these are base units. So to convert from base unit to units with prefix, right, you divide. So for example, this one, so you want to convert from 0.05 meters to nanometers. What you do is you will just divide by the nano is 10 to the power minus 9. Then you get your answer. Then if it's base unit, the units with prefixes, you want to convert to base unit, such as this case, right? So what you do is you just multiply by the factor. So this will mean it's 6.85 times a micro. Micro is this much. Like that. Okay. So you have scalar vector quantities. So scalars are quantities with magnitude only, that means a value. Then vector is those with magnitude and direction. So there is a list down here. So the list separates scalar from vectors. They sometimes appear in MCQ. So they can give you a list and then after that say which of these quantities are scalar quantities, then how many are there? They'll ask you to count. Okay. So then you have measuring dimensions, measuring physical quantities. So length is the distance between 2 points. So SI unit will be meters. So they will ask you to choose which instruments to use to measure a certain length. So big items you usually use measuring cylinder and meter rule. So then the accuracy is up to 0.1 centimeters. So your answer is in 1 decimal place. So vernier calipers, right? The answer is for uh anything that's shorter than 12 centimeters, but not too small, not exactly very, very small. So that one, the answer is to 2 decimal place. Then micrometer screw gauge is for those dimensions that are very small. So it's in 3 decimal place if it's centimeters, then 2 decimal place is in if it's in mm. So they ask you to choose, you just pick. Then this is how you read the vernier calipers. Do I have to go through this? You there?
Yeah.
Do I have to go through this?
Yeah.
No.
Yeah.
So yes or no? I can't really hear.
Yes.
Okay. So there are 3 steps to this. So you will see the scale appear, this thing appear on your vernier calipers. Okay. So there is a mean scale and then there is the vernier scale. So this is the mean, and then this part at 0 to 10, this is the vernier scale. So what you do is then you go to the 0 and read the point before it. So it's 6.3, right? 6.3. So then you get 6.3 already. Then you just write 6.3 something. Then after that, you go back and then look for the line that coincides, where the vernier scale and the mean scale, the number coincide. So this line. So the the line that the point that coincide at, right? You read the vernier, and then you see it's like the 5 mark. So then the reading will be 6.35. Okay.
Yeah.
This one, I don't see that in structures a lot. It's usually in MCQ questions. Then this one is the micrometer screw gauge. I assume I also have to go through. So then this will be the main, and then you have this other scale lah, call it vernier also lah, easier. Okay. So again, you just look for the point before this vertical, this divider. So on top, right, is 1, 2. So on top is 1 division. Then anything below is 0.5 division. So that means here at this point here is actually 2.5. 2.5 something. Then after that, right, you will proceed to this section here. So you will look for the line that coincides with the horizontal here. So you see this. So then this is like 0.29 because in mm. So what you do is you take 2.5, then after that, add on the 0.29 like that. Then you end up with 2.79. Okay. So I did not cover the 0 error because I think 0 error is not tested. So there are 0 errors for this and this. I conveniently left them out. If you see them appearing in your paper, then we will talk about it again. Then if you want to measure time, time is in seconds. So you have a pendulum, then going left and right and come back, right, to the same point. This one is 1 complete oscillation. So to find a period, you let this swinging go for 20 times. Then after that, you just take the total time taken for 20 oscillations, divide by 20. Then you get the period. Okay, so the period is affected by the length of the pendulum. So length increase, period increase. Then the period is not affected by the mass and the amplitude of the oscillation. So for chapter 2, this displacement and this distance, you need to know the difference. So distance, right, that means it's covering the total length. Then displacement is only you only measure the shortest distance. SI unit for both is in meters, then one is scalar, one is vector. Then speed and velocity is just like this distance and displacement. So speed is distance over time. Then velocity is displacement over time. Units for both is the same. Then you have these three terms. You have constant speed or constant velocity. That means if it's constant speed, that means it's same speed throughout, same velocity throughout. Then instantaneous speed is the speed at a particular point. So if you want to find instantaneous speed, like time equals to p, you draw a tangent here, math question. Then you find the gradient. Then average speed will be total distance divided by total time. Then acceleration is calculated using this formula. It's the rate of change of velocity. SI unit, take note. Then something has an acceleration if there's a change in speed or there's a change in direction. I think this one, this one shouldn't be here. This few things shouldn't be here. Okay, then the units are there already. Then this is commonly tested in structures. So you have distant time graph, they ask you to interpret the distant time graph. So the gradient of a distant time graph is speed. So these few things, we done some recalling the other day, but I think this will help you describe in your questions. So horizontal line is z-res. Then straight line like this is uniform speed because uniform gradient. Then this is increasing speed. Then this is decreasing speed. Then speed time graph, the gradient is acceleration. Then if you find the area under here, right, then this is a distance traveled by the object. Okay. So this view is what you need to know. I think the other day also went through already. So you just refer to it. Okay. Then this is for for cases where you have someone, then you throw a ball up and then the ball falls down. So A is here, B is here, and then C is at this point where it hits the ground. This is a standard graph for this kind of question. So there are a few effects of forces. So it makes objects speed up, it makes objects slow down, then it change the direction, then change the shape, make the stationary object move, and then make a moving object stop. This MCQ. So you have a few types of forces. They won't ask you outrightly to list, but it's I mean it's good to know that such things exist. So you have frictional force, tensional force, all these are contact forces. Contact forces means the force is only there because it's a interaction between surfaces. The two bodies are touching. Then non-contact force is the force that is exerted by another object which is not in contact, is at a distance. So gravitational force, electrical force, and magnetic force is the only three, and gravitational force takes a whole lot of percentage for you. Then Newton's three laws. Three laws for you is one and two. Third is not so important. They may ask you to write down what the three laws are. And then this is an extension of Newton's second law. So resultant force is mass times acceleration. So there's another thing about balanced forces and unbalanced forces. Balanced force means two forces are the same value and they are acting in opposite directions. So then eventually you will get a resultant force of zero. So acceleration is zero. So when that happens, you will have something that is at rest or is stationary or something that moves in at constant speed. Then if you have unbalanced force, right, then you will have acceleration. So this is Newton's first law. This is Newton's second law. So you have F equals to ma here. So in a situation where you have a question like this, and then they say this is moving at constant speed, means A is zero. So when you find the force, right, resultant force is equals to zero. This kind of question. Is it constant speed? That means that resultant force is zero. Then you have friction. Should I go through this? So it's a force that you exist, right, when there are two surfaces rubbing each other, then friction will be like in between them. So friction opposes motion. You have air resistance is also a form of friction. So this sometimes may appear, not very often right now. So the pros and cons of friction. So where and tear is a very commonly seen answer. Then how you reduce friction, you use ball bearings, you use air cushion, and you use lubricating oil and greases. Mass, weight, density. There's this thing called inertia. So it's like this. You have a person and then it's traveling in a maybe in a bus. So the bus is not moving. Then after that, when the bus starts to move, this person will kind of jerk backwards. That is because the body has a resistance to the motion, so it will want to try to stay at its original position. Then when the bus suddenly stops, then the person will jerk forward. Because this is because the human is moving forward together with the bus, and the bus suddenly stops, the human body continues to move forward because it's reluctant to stop. So this phenomenon or this observation is actually inertia. If they ask for definitions here, so the bigger the mass, the greater the inertia. So the jerking forward and jerking backward motion will become bigger. Then you have gravitational field. They might ask you for the definition. Then units. Then gravitational field strength. This is also a definition for this. This is a definition for gravitational field. So on Earth it's always 10. So this is your G. So if you want to calculate weight, then weight is equals to mg, then G is 10 here. So you need to know the difference between mass and weight. So mass is to measure the amount of matter. Weight is measuring the force acting on it, the gravitational force acting on it. So mass doesn't change, and then weight depends on the G. So it which are different on different locations, different planets, weight will be different. Then one SI unit is kilograms, one is in newtons. Mass is measured by beam balance. Then the other one is by spring balance. This one is mostly MCQ these days also, but sometimes it will appear as a one-liner answer. The kind of thing. Density. Definition is here. My internet connection is unstable. If I disappear, please text me. Okay, so density is mass per unit volume. So the units is usually kilograms per cubic meter, but sometimes we use gram per cm cube also. So if we were to do calculation, then mass will be in kilograms and then volume will be in cubic meters. If it's in this, right, then this will be when you do your working, then this will be in grams and then this will be in cubic centimeter. Then another observation is less dense object will float. Then the more dense ones will sink. So that's why you got this. So A is more dense than B, C is more dense than B. Now A is less dense than B, C is more dense than B. Moments. Then moment definition here. Then you have two things, two moments. So it's going in clockwise direction or anti-clockwise direction. Moments is dependent on force and perpendicular distance. Then the SI unit for moments is Newton meter. To calculate moments, you have force times perpendicular distance. So this one is important. They might ask you to state the principle of moments. They must ask you to state this. So you have clockwise moments equal to anti-clockwise moment. So if your clockwise moment is lesser than anti-clockwise moment, then you will turn in anti-clockwise direction. Then if the clockwise moment is greater than anti-clockwise, then you will turn in the clockwise direction. Okay. Okay. So you have CG. CG is often, for regular objects, is often in the center. So we say that an object is stable or not stable, right? Stability means whether the body can go back to its original position when you tilt it. So factors affecting stability will be the position of the center of gravity. So it should be as low as possible, then the object is stable. Then base area is as big as possible, then you can get a stable object. Then you have three equilibrium: stable, neutral, and unstable. So stable means you tilt it, you will go back to its original position. Then you take note of the position of the CG. So CG goes up and come down again. Then the neutral one is the position of the CG will always be the same. Then unstable one will be you tilt it, then the CG will go up. Then you continue to go up and then the whole object will fall. So the object will fall and then you will revert back to the original height or lower position for the CG. So there's this three. This question, they usually will give you a structured question and they give you an example, maybe a toy or whatnot, then they ask you to describe. Pressure, nothing much. Definition is here. So it's force acting per unit area. So area is the cross-sectional area or the contact area. So units are here is in either Pascal or Newton per square meter. Sometimes they will use Newton per square centimeter, and this is not equal to Pascal. So factors affecting pressure is these two, force and area. So if you have a small area, then you have high pressure. Then if you have a big force, then you have high pressure. So the reverse is also true. That's all. Then energy, the definition is here. Then they would want you to state principle of conservation of energy. So energy cannot be created or destroyed. It can be transformed from one for another, and the total energy is constant. The SI unit is in joules. Then
will they ask to calculate for any other energy except for kinetic and potential?
they can do that under conversion energy. So maybe say you have a fan, okay? Then the fan runs on battery. Then after that, then you press the switch, then it becomes the fan will give you kinetic energy, and it will give you sound energy and heat energy. So that means, right, so it become chemical, become Ke plus light, no, not light, sound and heat. Okay, so then they can tell you, you can find this. Then after that, then they say maybe 30 joules of sound energy and 40 joules of heat energy is also dissipated. Then they ask you what is the chemical energy present. It's possible they can do that under conservation of energy question. But they must give you the info. In this case, they want you to find the chemical energy, then they have to give you the sound and the heat. Something like that lah. But it's always, this kind of question will only exist if they do energy conversion. Most of the info is given to you. If not, then you are restricted to KE and PE. Then you have the famous roller coaster question. They have the pendulum question. Those are the ones that more commonly seen, which only involves KE and PE. Then the rest is not. But those questions, they can ask you to calculate the work done against friction, which is also using the same conservation of energy to do. So these two, if you've forgotten, these are the two formulas. Then KE is depending on motion. Then PE is depending on position. So a moving object has KE. Then an object that is very high up or above a certain above the surface of the earth, right? Then they will have certain amount of PE. Then you have work done and power. Work done is force times distance. Then is in joules. Then power is the rate of change, rate of at which work is done, or rate of change of work done. So, or rate of change of energy change. So the SI unit is in watts, and then the formula is over there, work done divided by time. Then this one, you are supposed to know how to draw. Then you are supposed to be able to describe the motion, the attractive based on, yeah, you have to describe based on motion, which is one is in vibrating in fixed position, the rest are not. Then you have the attractive force, how strong is the attractive force, then the arrangement and the distance between particles.
If they ask to draw, need to draw how many particles?
Something that can fill a small square, 5, 10, depending on how big circles you have. I think 9 would be good if you have a solid. Then it becomes like that. 9. Then after that, you can draw 9 and then draw 9, but the square will become bigger. Okay. This one. This one is the primary school one that you need to know. Then you can use this to explain this. Then there are certain questions here like why solids and liquids have fixed volume but gases don't have. So the explanation is there. So solid liquids are not free to move in all directions. So they have fixed volume, then gas can move anywhere, so their volume is not fixed. Then fixed shape also similar, same reasoning. Then solids have high melting boiling point. This one, right, is dependent on the attractive force between the particles. So solids have strong attractive force between particles. Then liquids and gases do not, so the melting point for solids is higher. Then diffusion is because of the movement of particles. So particles in gases move faster, so you get more diffusion. Then the last one is why gases can be compressed and liquids and solid cannot, because the distance between liquids and solid particles are very small. But the actual explanation is there. So this is given to you because I included this picture so that if you happen to come across this question, you can just take the answer from here and just write it in the paper. Okay. Then temperature, this difference between temperature and thermal energy. One is to measure the degree of hotness and coolness. Then thermal energy is just energy. Then you have the SI units and all this. They are different in some sense. Okay, so you have to know how to describe conduction, convection, and radiation. So they give you a case, you have to be able to write it out. So it will be good if you run through this again. Look through a bit. So there's one. So one is the not metals, non-metal. This is non-metals. So non-metals, the particles will vibrate, and then energy from one layer of particles will transfer to the other layer via collision. So it take a while. Then if it's in metals, right, then there will be free electrons. The free electrons will carry the energy from the heat source to the other end of the metal. So the first one will tell you that solids are better conductors than liquids and gases because solid particles are very close. Then metals are better conductor than other forms of solids because it has electrons that can move. So this one, possible question that they ask, why are liquids and gases poor conductors of electricity? Poor conductors of heat because the particles are far away from each other. So the transfer energy via collision will be very, very slow. So poor conductors, they are also known as insulators. So convection happens when the particles move. So any particles, so in solid, liquid, and gases, right? Only liquid and gas particles move. So liquid and convection will only happen between liquids and gases. So this one based on the expansion and contraction of fluids. So any fluid that gains energy, they will expand, and then they become lighter. So they less dense, so they will rise. Then the cold portion of the liquid will have higher density, so that the higher density part will sink. So that's why I got this thing. Convection works on this. So this is the diagram. So it goes according to 1, 2, 3, and 4, the process. Then radiation is the transfer of heat via infrared waves. So it doesn't require any medium. So radiation is affected by color and texture of surface, the surface temperature, and the surface area. Then this one is important. So black and dull surfaces absorb and radiate heat better. Then it doesn't reflect heat well. Then smooth and shiny surfaces are poor absorbers and radiators, so they are good reflectors of heat. Then surface temperature, a higher surface temperature, there's higher radiation. Then surface area, if it's bigger, then there's more heat that can be released using radiation. So the vacuum flask, they may ask. So there are different parts of the vacuum flask, they serve a different function. So you might want to take note of this. Then internal energy. Internal energy consists of potential energy and kinetic energy of the particles. So so potential energy component, right? Potential energy component is dependent on the intermolecular forces and distance between particles. So molecules with more potential energy, they are far further away from each other. So potential energy is dependent on is affected during the change in state. Then kinetic energy is, or kinetic component, right, is dependent on the temperature of the substance. So if the temperature is high, the Ke component will be higher. So you have heating curve, important. Heating and cooling curve are quite important. So you need to be able to identify where is solid, where is liquid, where is gas. Then where is the melting, where is boiling, because they can ask you to identify what is the melting temperature, what is the boiling temperature. So then they can ask you what is the arrangement of particles somewhere, like here. So then you have to tell the marker, you can write, you have to write the answer, say the particles are in fixed position, blah, 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 blah. The slides, the answers are on the kinetic particle sites, kinetic particle theory slides there. So you have to know how to explain those things. They ask you to write. Then this is what happens during melting. They can ask that too. So heat is absorbed to break the attractive force between particles so that the particles can move about. Then boiling, heat is used to break the attractive forces between particles so they can move around freely and randomly in all directions. So the cooling curve is the reverse. So again, same as heating curve, they can, yes? Do you try to say something? So if it's a cooling curve, they will ask you to identify where solid, liquid, and gas. They will ask you for the freezing point and the point where temperature change from gas to liquid, possible also. So what happens during condensation? The motion of the particles become less vigorous. So it will form back attractive forces between particles when gas change to liquid. This they may ask. Then can say what happens during freezing. It's also they will release heat. Then the attractive force can be formed between particles. Then they will change from irregular arrangement and they will go back to the regular pattern of the fixed when they have their fixed positions. So this one important. What is the difference between boiling and evaporation? So boiling only at one temperature, evaporation on all temperatures. Boiling is happen throughout the liquid, evaporation only at the top. Then one has a temperature change, one don't have. So this one take note. Factors affecting evaporation: temperature, boiling point, surface area, humidity, and the atmospheric pressure. I shall not go to the details of every one of them. Okay, so these are the bare minimum you need to know. So wave property, so what is waves? They transfer energy. Then they may ask you to explain how waves is formed. But the most important thing is these few wave terms, because a lot of the question hover around asking you to find wavelength, they ask you to find amplitude and whatnot. So wavelength is on the diagram. So if they ask you to read from a graph, I hope you know where it is. Unit is meters. Then amplitude is the height here. Then amplitude and energy. So if you have high amplitude, means there's high energy. Then period is the time taken for one complete wave. So the unit for period is seconds. So frequency is the number of waves in 1 second. The frequency is in hertz. So you must know how to identify which one has high frequency, which one has low frequency. Okay, so the calculation is here. Frequency is 1 over period. So when period decrease, frequency increase, and the number of wavelength will increase. That means this is number of waves. Number of waves will increase. So if you have a long period, then the frequency will drop, then the number of waves will drop. Then calculate speed, you can calculate in this manner, distance over time. So the distance can be found on the displacement distance graph. Then the time can be found from the distance time graph. Or this frequency, speed is frequency times wavelength. There I go. This is the distance time graph. You find period here. Then you can find amplitude here. Then you have a displacement distance graph. You will find wavelength and you will find amplitude. So with those things, right, these three things here, period and amplitude and wavelength, you can find frequency, you can find the speed of the wave. Wavefront is an imaginary line. It somewhat resembles the water wave. So wavelengths, points on the same wavefront will have the same phase. That means if one is in crest, right, the other one will be in crest. We have transverse waves, identify how they look like and differentiate. So transverse waves, the wave motion and the movement of the particles is perpendicular. Then longitudinal waves is the wave motion and the movement is parallel to each other. The electromagnetic spectrum, this. You can read up on the users and then also remember the users, but I have not included it. Okay. Sound. They will ask about how sound is being formed. Then you need to know about air pressure. Regions of high air pressure is compression, and regions of low pressure is called rarefaction. Then the particles move left, right, and the progression, the wave is also good. Wave motion is also left, right. So this is done. Then you have the sound graph. It's a pressure distance graph. Then it gets converted into a sine graph. Yeah, yes. What? Sorry, couldn't catch you. Should I continue?
Yeah. Yeah.
So pressure distance graph will be converted to a sine graph like this. So the peak, right, is the compression, and then the trough is the rarefaction. Compression, compression, rarefaction. So way to measure, I don't think they'll ask you to measure, they will ask you to calculate the speed of sound. So there is a direct method where you have one person shooting the gun and the other person watching. Then speed is distance over time. So the distance between the two of them. Then nothing is, if you look through your mistakes earlier in the earlier lessons, right? The question, sometimes they'll ask you what is the speed of sound. Don't be too quick to jump into the answers and then say, oh, it's 330 meters per second, or it's 325 meters per second, or it's 300 meters per second, because those speed will change according to the question, because most of the time they want you to calculate, not to state the standard numerical answer for speed. So you have to watch out that one. So how you improve on the experiment, just have some impression can. Then you have the pitch and loudness. So high frequency is high pitch, low frequency is low pitch. Okay. Then the loudness is dependent on amplitude. So high amplitude means a loud sound, low amplitude means it's a softer sound. Then this is the echo. Again, it's a lot of description, but I think for you, they will give you the info and they'll ask you to calculate the speed of sound or the distance between the walls or distance between the seabed and the ship, etc. They give you the story. So you have to take note if it's an echo question. If it's an echo question, is this speed is distance divided by time, but the distance is 2 times of the distance. 2 times of the height or 2 times of the length, etc. Because it's an echo. So you have to watch. If you give you a calculation question, you have to take note of this thing. Whether it's one echo or the direct method. Electricity, you have to remember most of this. You don't have to remember this. You don't have to remember this. Don't need this. Don't need this. I don't think you need it at this point of time. Yeah, these are the few that you need to know. So you ask you what is the electric current, they can ask you for the definition. Then this one, the SI unit is ampere. Then it's measured by ammeter. So calculation, it's very important. So current is charge over time. Charge is in coulombs. Then electromotive force, they ask you for a definition. Definition is this one. Then potential difference, the definition is this. But all of them, their units is in volts or joule per coulomb. They may ask for this. What is 1 volt? Then means that 1 volt is 1 joule of energy done by a source to move a unit charge around a complete circuit. So for EMF is a complete circuit. Then the PD, right, is across a component. PD is across a component. But the PD, right, the unit is also in volts. So back to this calculation of EMF, the formula is this. So this is energy or work done, then divided by charge. Then PD is also the same formula. Then resistance is a property of the material to resist the movement of electrons. So the size of the resistance will affect the current. So if there's high resistance, means there's low current, and if there's low resistance, that means there's high current moving through the wire. So the SI unit is ohms. They may ask for definition. The ratio of potential difference across it and the current. This one. Resistance is V over I. Calculation in this chapter is important. So if you can't remember any definitions, please at least remember the formulas. So this is the definition of 1 ohm, is the resistance of a material through which a current of 1 ampere flows when a potential difference of 1 volt is maintained. So as I said, if you cannot remember the definition, at least remember the formulas. Then you have this effective resistance in parallel and in series. So this is a parallel circuit. This is a series circuit. I am quite positive that you know how to differentiate them. So if it's resistance in series, what you do is the effective resistance will be just R1 plus R2 plus R3. Then if it's resistance in parallel is this.
R1 plus 1 over R2 plus 1 over R3.
Yes. So this one, they will confirm, they will ask in the calculation question.
Then to find the effective resistance, must flip the fraction.
Yes. Yes. So you add up already, then you flip the fraction, then you get effective resistance. Then the factors affecting resistance in the wire, which is length, the cross-sectional area, and the type of material. So if you have long length, larger resistance, short length will be shorter resistance, smaller resistance. So cross-sectional area is like this. Area is cross-section is big equals to smaller resistance. Then type of material, that will depend on the resistivity. Depend on this. Yeah, so if they give you numbers in the question, just put in the numbers. Then resistivity is a constant number. So if you see different materials, they have different resistivity. So you have a high resistivity, right? That means this has high resistance. Okay, last one. Last slide. So if you do DC circuits calculation question, so you must take note of these few things. In a series circuit, the potential difference will add up. So you have two resistors, right? The potential difference here, right, will be the same as here. After your WA, I will go through this again. Go through the questions at the calculation question. So current flows in one loop here. So current is always the same in series. Then the effective resistance, you already know what it is. Then for parallel circuits, right, this case, right, the potential difference is the same throughout. So potential across the first resistor and the second resistor is the same as the EMF of the source. Then current will split. So that's why current goes to I1 and plus I2. Then the effective resistance, the formula is this. Okay. Then I haven't done this. So this is all I think you probably need to remember for your WA if your WA is from chapter 1 to the last chapter. Yeah, the bare minimum. Okay. Okay. Then if there's nothing else, I see you at 3:30 later. Then you can tell me the outcome of your test in the morning. Then what else? Yeah, I think about that. Then I shall not hold you any longer. We are only doing a 1 hour session right now, right? Yeah. Then you go and okay. So after all my mumbling and rambling and whatever, right? I think you will know which part that you are lacking, and you cannot remember. You should probably try to take the rest of the time and catch up on those things. Okay. I couldn't do much. I can't really do example of questions right now because the time is very tight. And not possible for me to go through every single question. So I chose to do a summary of this to trigger your memories.